Thank you. Good afternoon, everyone. So as mentioned, it's going to be a slightly different tutorial. We're going to start off with a half-hour talk as usual, but then I'm going to kind of walk through the first half of the notebook with everyone. So hopefully I can get a few more people engaging with the material, and less of you are inclined to check your email. Right, so what is Wave? So Wave, in a nutshell, is an authorization system that permits delegation of permissions. So if one person has some permission to access something or control something, they're in a position to delegate a subset of the permissions that they have to another device or service. And the system operates without trusting a centralized server. You could imagine that delegation, as I just described it, is a trivial thing to do if you just have an Active Directory. All it is another row in the database. However, if you're trying to design a system that operates without any trusted central server, there is no Active Directory, it becomes a much more challenging problem. And the solution is everything is enforced cryptographically. So what is Wave useful for? Well, when would you actually consider using the work that you're going to be seeing today? So Wave can be used to secure communications. It can be used to encrypt messages. It can be used to attach proofs that the message or action is authorized. And it provides authentication and authorization at the same time. So this is something that can replace OAuth. You can replace uses of Active Directory. You can replace your typical bearer token authorization and authentication. So it solves many of the same problems that you typically see authorization and authentication frameworks doing, but it does all of this while avoiding centralization and permitting fine-grained delegation. So why avoid centralization? Why are we going to such lengths? Well, the biggest reason is, of course, that it's a point of weakness. If you look at almost every single breach of an authentication server over the past couple of years, it's associated with millions of records being leaked, people's usernames and passwords and details being leaked. Obviously, if you manage to compromise one of these central authentication authorization servers, you can subtly and quietly do any action that you want because you can just inject your own authorization policies. So avoiding this central point of weakness drastically reduces the attack surface of any services that use it. So how does this work? So Wave allows participants in the system, whether those be devices or services, to form a proof of the permissions that they have. And you can then attach this proof to interactions that you have with other parties. This proof can then be verified non-interactively, so this is actually quite a big change from a bunch of other systems that have occurred previously. If you receive a proof, you do not need to communicate with the person who has generated the proof in order to validate it, and you don't have to communicate with any central server, obviously. So this allows it to be used in asynchronous communications, and publish-subscribe, as we're going to be doing in the tutorial today, is one good example of that kind of asynchronous communication. Permissions can be granted to any participant. And when I say any, I mean any. So if you have Wave being used in one company, you can grant permissions to an entity or a participant in another company, and it remains trustworthy. Neither company sort of really needs to trust each other in order for those permissions to be valid. So this allows Wave to be used for federation across administrative domains, potentially at a global scale. What this means is, although there are many servers in Wave, and these are spread out across multiple companies, it still forms a single global system where proofs can be formed across all of these administrative domains and validated across all of them as well. So I'm going to go through some of the basics of Wave so that you have an idea of what these things are when you get to using them. So the fundamental thing in Wave is an entity. Any user of Wave, whether that be a person, a service, or a device, is represented by an entity. In the next following slides, I'm going to use a sort of green man as an entity, but you can think of this as being a device or something like that as well. An entity has a secret part and a public part. Each of these contain multiple public and private keys because we enforce everything cryptographically. There are a lot of keys involved. And the public part of this entity is referred to by its hash. So if I want to refer to you, your entity, I refer to it by this hash of the public part. And it looks something like this. You're going to be using those a lot in the tutorial. Then, in order to actually grant permissions between entities, you create something called an attestation. So an attestation goes between two entities, and it's capable of delegating a subset of the permissions that the initial entity has to the recipient entity. These attestations are encrypted, but they're made publicly discoverable. Unfortunately, we don't have time in this talk to really go into the nuances of the storage system in Wave. However, it's suffice to say that any attestation that you created is publicly accessible in its encrypted form. All of these attestations form a global graph of authorization that crosses multiple administrative domains, and this looks something like this. Imagine you have the entity representing a house that grants to a server, which grants to a light bulb, which grants to a person, and there's multiple of these entities granting different permissions all around the space. This global graph is kind of basically every attestation that is created, and it spans multiple authorization domains. For Wave, basically everything just looks like an entity. It doesn't matter that some of these are people or some of these are devices. Everything is just an entity. So these attestations are discovered by every entity that can use them. So every entity will go out into this global attestation graph, and they will decrypt a portion of this that they can use to form proofs. And this is called the perspective graph. So if you imagine that this is kind of our global attestation graph, and everything in the dotted red arrows here is something that's encrypted. It exists in public storage, but you can't see it. You can't see any of the information in it. From the perspective of a single entity in this graph, a subset of those will be decryptable, and that they can then use them in the proof. Now, Wave handles all of this for you. As a user, you don't have to go out and manually decrypt anything. This is all handled behind the scenes, but it is important to understand how we sort of maintain privacy in the system. If you change which entity is looking at this graph, say we make it this entity at the bottom here, that perspective graph is going to be different. And the perspective graph, as you can see, is all of the arrows that have a path to that entity. Everything that doesn't enter that entity, which means that it doesn't concern it, is not discoverable. So every other attestation that doesn't lie on that path is not decryptable. So what does an attestation look like? We've seen that it forms this global graph, but what does an individual attestation actually look like? So basically, it's just an object that contains the attesting entity, the one that has permissions and is busy granting it, a subject entity that is receiving permissions, then it has a description of the permissions and which resources those permissions concern. So the entities, as I mentioned earlier, are just referred to by their hash. And then, obviously, we attach some cryptographic signatures so that this object cannot be forged. Only an attesting entity, that particular attesting entity, could create this object because it was signed by that entity. The permissions are a combination of a permission string, which is a free-form string like read or actuate or write, and a permission set. And the reason we have this permission set is it sort of acts as a namespace for the permission string, so that if I grant you the ability to write in my application, and that doesn't accidentally get confused with the permission to write in a different application. So if someone is sort of testing a proof, it is unambiguous what these permissions actually refer to. So a permission in Wave is this combination of a permission string and then a permission set, which you can think of as kind of being a schema reference for what those permissions are. Similarly, our resources are a combination of a URI, which is just sort of like a free-form URI as you're accustomed to in other domains. But each of these URIs are within a namespace. In the same way as a URI on the web typically starts with a host name of a server that is kind of the domain that resource is within, every resource URI here starts with or is associated with a namespace that is the entity that has all of the permissions on that domain that created the set of resources, that it's considered the authority for these resources. And a URI could be something like an API function. If you're granting permissions on APIs, it could be a path to a file, or it could be a path to a physical device in a room or a department. It's really free form, and the hierarchy there is up to you. So what does a proof of permission look like in the system? Well, a proof is a path of attestations with their decryption keys, a path of attestations that begins at this namespace entity. So within the resource, there's that namespace entity. It starts there, and it ends at the proving entity. And the proving entity in this case is the same as the perspective entity. So this is a path inside the perspective graph. So in this case, it would be these three attestations here. And the reason that this is a sufficient proof that the proving entity has permission is because the namespace entity has absolute permission on all resources, and each of these delegations, each of these attestations here grants some permissions that flow down the graph. And so the final permissions that the proving entity has are the intersection of the permissions granted by each of these edges. Wave is also capable of doing message encryption. And we do our message encryption using a namespace and a resource URI as a sort of a public key. And this is a really powerful tool, because what it means is if I want to send a message to associated with a resource, say on a publish-subscribe system, or if it's an email and I'm associating with a mailing list, anyone can encrypt it using this namespace and this resource URI. And in order to decrypt it, you need to be able to form a proof for the decrypt permission on that namespace and URI. It means that the ability to decrypt messages in Wave is governed using the same permission system that you use for any other type of permission within Wave. There's obviously a lot that goes on behind the scenes to enable this, but from a user's point of view, it just looks like a seamless, the ability to decrypt is the same as any other permission. So essentially, when you build the proof that you have the ability to decrypt, that process of building the proof, which Wave does for you, also discovers the keys that enable you to decrypt the message. So let's talk a little bit about how Wave is used. Well, what does the architecture diagram look like in a typical deployment? So let's first look at the status quo. What you typically have is an application or a service that is communicating with another application, and they both have this shared authentication server. It may be in some systems that the first application will send a username and password, and then the second server will contact the auth server to validate it. In other applications, like bearer tokens, the first application will contact the auth server and get back a signed token, which then passes on to the other one. But in general, there is some shared authorization server that sits there, and you pass a message along with its associated credentials. In Wave, every application and service has its own running Wave daemon that's local to it. This is supposed to be within the same trust domain, so if there's an application on a server that's using Wave, you would typically run this Wave daemon on the server, and it would communicate over IPC or something like that so that it's a secure link. And then when you communicate with other applications and services, they also have their own Wave daemons that are within their trust domain, and you will send them an encrypted message with a signature that proves that a specific entity sent that message, and then you will attach a proof. And the receiving application can then validate that proof and say, okay, this message is attempting to invoke this function. Does the proof prove that that action is valid? Or this message is attempting to control something. Is that valid? Or this message is purporting to be from a particular entity or speak for a particular organization. Is that valid? So this proof is really a very general mechanism that can be used for a variety of different things. So just a couple of the operations that you would expect these services to do with Wave: creating a new entity, building a proof. As I said, Wave does all of the work of decrypting the graph and forming the proof for you. So you just ask it, give me a proof that gives me the following permissions, and it will go out and build it for you. You can ask it to encrypt a message, to sign a message, and then it's up to the application to transport that resulting proof and message over to another application instance. And then on the other side, you would pass that through to Wave and say, verify the signature on this, decrypt it, and verify the proof, and tell me what permissions that proof actually gives you. So the tutorial today is going to cover some of the low-level elements of Wave. We're going to learn how you build a proof. You're going to learn how you verify a proof, how you grant permissions, how you can encrypt and decrypt messages, and then how you can work with entities across namespaces. You're actually going to be controlling things that are running in your partner's laptop. So someone next to you, you're going to be controlling things running there. So just a word of warning, this tutorial is deliberately low level. Typically, as a user or developer, you would be using libraries or something that have been written using Wave. We decided that we would target this at a low level so that you can learn how to use Wave in your own applications. The particular tutorial we're doing today is a publish-subscribe sort of IoT system. There is actually an already implemented high-level system for doing publish-subscribe using Wave as an authorization mechanism that is already quite advanced, that has tolerance for intermittent connectivity and all sorts of other features. This is called WaveMQ. I encourage you to go and check that out if what you're wanting to do with Wave is very similar to what we're doing today. We're deliberately not doing that because it's too easy to use, and we wanted this tutorial to actually kind of teach you some of the low-level stuff. Again, just a reminder, this is not what a user sees. This is what a developer sees. We're showing you how developers work with Wave. So just a quick overview of the tutorial. You're going to create an entity that represents you, and everyone here in this room is all connected to a single publish subscribe MQTT server. And so you're going to choose a little nickname for yourself that's used to partition your communications on that server, and you're going to communicate with your house over MQTT. It's not going to be a library call to the object, cheating within it. You're going to be acting as if you were an external party controlling devices in your house. You're then going to sort of learn how to actuate them, learn how to decrypt data from them and verify proof and so on. But then you're going to move on and you're going to control devices in someone else's home, someone sitting next to you. You're going to control their devices, learn how to decrypt data from their devices and so on, and kind of learn how Wave would be used in the real world. So I'm going to, there's a short sort of tutorial feedback form that I'm going to ask you to fill in at the end. I'm actually going to jump into the notebook now and kind of walk through some of the early parts of the notebook with you. But if you would like to take a picture of this, you can go and fill in this form at the end of the tutorial. I believe that there will also be an email sent out that contains these links. Yeah. Yeah, do we have a mic? Anyone? I guess you can ask questions out. You just have to speak loudly. So yes, you can. Revocation exists in Wave. We don't actually do revocation in this tutorial because we're a bit pressed for time. But if you have some time during the tutorial, you can play with it yourself. The full Wave API is available, and you can call the revoke function. Yes, Wave has revocation. Yes, so you do, when you'll see in the tutorial that there is a field when you grant permissions called indirections. And this basically specifies how many times that permission can be further delegated. If I grant permissions to you and I set that field to 0, then you're not permitted to further redelegate it. Academically, there is a lot of argument about this topic because if someone is sufficiently motivated that they want to share permissions, they can always proxy requests from someone else. But despite the fact that there's a lot of disagreement in the academic community, we do have that feature in Wave. You can limit further delegations of permissions. Right, so if you go to the risecamp.tech webpage, you should see that there is now a link for Wave that has appeared there. So if everyone can open that up, and you should find yourself in a Jupyter Lab dashboard like this. So if anyone is having trouble getting to this point, if you could just raise your hand quickly, and we'll sort that out. Okay, looks like everyone got there. So the Wave tutorial is here on the left, and the first thing we're going to have you do is right-click this tab up here and click New View for Notebook. And this is because we have our little virtual house running on the notebook, and it's a bit inconvenient to have to scroll up all the time to look at this virtual house when you do something like actuate a light. So if you click New View for Notebook here, you will get another notebook tab that opens, and one of these you will use for looking at your virtual house, and one of them you will use for doing the rest of the tutorial. So in this first cell here, you have to pick a nickname for yourself. Everybody pick a unique nickname that no one else in the room chooses. If you happen to choose something that collides with someone else, you will get a lot of permission denied messages showing up because you will receive other people's traffic with invalid proofs. So I recommend you pick something like your first name and last name and then some kind of random digits. And then run the cell, and this will basically boot up your virtual house. You're going to get some virtual devices here. And this is kind of going to represent your home. Now, because of how IPython or sort of Jupyter Lab works, one of your tabs is going to have a little error message here that says something along the lines of widget could not be created. This is the tab that you're going to use for all of your coding. The other tab, the one where this initial cell displays these virtual devices, that's going to be the one you're just going to leave there looking at those virtual devices so you can go and refer back to it just by looking at the tab. So I'm going to hop over here and look at my sort of coding tab. So now that you've got your virtual home running, what we're going to do is jump right into this, and let's look at the namespace that is being created for the home. So this home with all of its devices has a Wave namespace, and it has a bunch of resources associated with it. And we can print out homeserver.namespace, which is this sort of entity hash that you see here. I think I need to maybe make this a little bigger. That's a little bit better. So this is the namespace. All of the permissions we're going to be granting, if it's for devices within our home, are going to be permissions granted on resources within this namespace. So now let's try creating an entity that's basically on the outside. So if we run this cell, typically what you would call is this wave.createEntity. So if you're doing this by yourself, that's what you would use. We were concerned maybe people would reset the notebook and then you would create a new entity. So there's a little bit of a wrapper function just for this tutorial here that buffers it to disk. But if you create this entity, you now have an entity object and it's saved in this local variable. And now you can sort of start using Wave with this entity. And the first thing we're going to do is we're going to try and form a proof of permission that this entity can control the house, right? So if you look over here, we're connecting to Wave. This Wave local variable came from the very first cell where we connected to the Wave daemon. And we're going to ask it to build a resource tree proof, and we're going to tell it what we need from this proof. So if you look at perspective, it was described in the previous cell. That's basically our entity. It's the secret part of our entity. So we give it the secret part of our entity. We tell it we're looking in our home server namespace. We want you to look for any permissions that exist first. That's what resync first does. And what we need you to prove is that you have the ability to write on smart home light control. And this is the permission set, as I mentioned earlier, is sort of like the schema for the permission. This is just something that's created in the background. So we're going to try and build this proof with our brand new entity. And what you should see is that you can't find a proof. Why would there be a proof? You've just created this entity. No one has granted it any permissions. You expect it to fail. So now, in real life, what would happen is you would take your entity, the public part of your entity, and you would go to a party that has permissions. That might be the person that actually deployed the service, so the home server in our example, or it could be someone who's received some permissions and is in a position to redelegate that. So you would go with your public key, and you would say, please, can you give me some permissions, granted to this public key? Where there are some mechanisms in Wave that allow you to sort of create some nice names, so you can say granted to this name. We're not covering that in this tutorial, but feel free to look that up later. And this process of going to someone and asking for permissions, we've wrapped up in this function here that just says, home server.grant permissions. And you don't need to worry. We're actually going to manually grant permissions later, so you'll see what this really looks like. But if I run this, I'm basically going to get a bunch of attestations from the home server that makes my brand new entity able to control things. And when I rerun this proof building cell, now it'll go and it'll decrypt all of the attestations and it will tell me proof building has succeeded. And what we have here in light proof, this variable contains the whole proof. You could print it out if you want. Unfortunately, it's a little bit large, so your notebook will be gummed up with a bunch of base64 output. But now we have this proof that is a path of attestations that leads from the home server to our entity that we can use for proving that actions are valid. So the first thing we can do is we can go and we can send a message to our home to tell it to turn on the light. So before I do this, if I do this and I go over and I look at this tab, my light is off. So this is our virtual home and we have our light within it. And that light is off. And if I run this, it now takes my proof, combines it with the command to turn the light on, transmits it over MQTT to a topic that the home server is listening on, and I go back and I look here, and my light is turned on. Now, this wasn't done through some local function API. There was no external sort of backdoor mechanism. This was done using the standard communication that anyone could have used over the internet. This server could have been anywhere, and this would have worked. And later, you're going to do it to each other. So I recommend that you sort of read over this first part here. I'm just going to give you a little bit of time to sort of look at how you build this proof. And if you have any questions on this, what's actually going on here, how those proofs are asked, just raise your hand. We have some volunteers who can go around and who can kind of answer your questions. This is kind of the fundamental part of Wave, creating entities, building proofs, and sending those proofs to other people. Just going to pause here for a bit, basically. So our smart home has a bunch of devices in it. We've just controlled the light, but we can also form a proof for something else. So now here we can form a proof for writing to the message box. If you go and you look at your virtual home here, you'll see there's a sort of a message box at the bottom. This is really a proxy for a notification system. When you write to this, your smart home would really be sending some push notification to your phone or something. And we can form a proof that shows that we're able to do that too. Now this looks much like the previous proof that showed how you built for the light. The difference is that we're proving on a different resource. So this time we're going to ask Wave, build a proof that we are allowed to write to the resource smart home notify. And you'll notice when you run this, it succeeds much faster than the previous one. The reason is, the previous time, it was busy building up the perspective graph. It was going out and it was decrypting the attestations, and it was building up a sort of local copy of attestations that it can use for build proofs. That's been done now. There haven't been any new attestations since then. So now, when we build this proof, it's very fast, and we have our proof immediately. And we can send a message to our home to the message box much the same way as we did for the light. So I can send hello world over here, and I can look at my message box, and I can see that I got the hello world message. So everybody run up to this point. And if you have any questions, yeah, please do. You can either ask a question out loud, or you can put up your hand. We have some people going around. We're now going to sort of turn things up a notch and build a controller that uses Wave to sort of control some stuff within your house autonomously. So what we're going to do is, so the objective here is to, if you look at your thermostat here, there is this occupied signal here. This represents, modern thermostats have an occupancy sensor in your house to tell you if they should be heating or cooling because they have an occupancy sensor there. We have this thermostat busy emulating this. So this occupied field goes from true to false sort of periodically, somewhat randomly. What we want to do is make our house a little bit smarter. When this occupied field goes to true, we want to turn on the light. And when it goes to false, we've left our house, we want the lights to automatically turn off. So this exercise will let you see what it looks like to be on the receiving end of a Wave message at a low level. Again, I mentioned earlier, if you're using something like WaveMQ, all of this is behind the scenes. But if you're trying to build Wave into your own applications, this is what it looks like to be at the low level. So if you scroll to the bottom of this next cell, you see we're doing an MQTT subscribe. So we're subscribing to the message that the thermostat is sending out, the report messages. And for every message that we receive, we want to execute this thermostat callback function. Now, when we receive this message, we have no reason to trust it. Remember, anyone in this room could be sending you that message. There could be malicious parties. So you have to start off treating this message as being a completely untrusted object. So the first thing you want to do is try and decrypt it. So this here, you call wave.decrypt message. You pass it your perspective, your entity secret. You give it the message payload. And you tell it, resync first in case there were any new permissions that allows you to decrypt it. And if you fail to decrypt the message, it probably means someone else in this room has the same unique nickname that you do. If you fail to decrypt the message, that's fine, just drop it. But remember, just because we succeed in decrypting this message does not mean it's trustworthy, because anybody could have encrypted that message that we can receive it. So this is the first step, but it's not sufficient. The next thing we need to do is break this decrypted message up into the proof and the body. And we can't trust the body until we validated the proof. So the next thing we do is we call wave.verifyProof. And the way that works is you give it your proof, and it will check that the proof is internally consistent. Everything is well-formed, and there's been no revocations, there's been no expiries or anything like that. And then it will take that validated proof and compare it against the policy that you need it to have. So the second parameter here, we pass it what policy we need this proof to cover. And as long as the proof grants a superset of that, it'll come back and say everything's OK. So what we need here is that whoever sent this message has a valid proof that shows that they can write to smart home thermostat report. And in actuality, only our thermostat has this permission. So we know that from that point that the message is valid. So if this proof fails, you'll get this response error over here. And then we just drop the message. You just treat it, some malicious actor is trying to hack me, you just drop the message. And then if it's valid, then you get this object here, body, and you can use the field within it. And so now you have to think a little bit. What you want to do is when the house is occupied, turn the light on. When the house is not occupied, turn the light off. Now, we've already directly controlled the light earlier with an MQTT message. So fill in some code here that enables you to sort of bind these two together. So when house occupied is true, you want to turn the light on. When it's false, turn the light off. So you should be able to just go back and sort of modify a previous cell, copy it in here. So everybody go ahead and do that. I will say, by the way, there are 3 points in the tutorial where we ask you to jump in and sort of code some stuff yourself. If you find yourself getting stuck, please raise your hand and someone can come around and help you. If you are still stuck, for every one of those, there is actually a solution cell. You can run this once and it will display the solution. And you can then read and see maybe what you need to change. If you want to just run the solution as is, you could just run that cell again and then the solution will take effect. And so when you've done that and you run the cell, what you should see is when you go across and you look at your house here, whenever that occupied field goes false, your light will turn off. And after a couple of seconds, when it sort of randomly changes to true again, you should see that your light comes on. So what you've done here is you've created an autonomous controller that's the recipient of wave messages. It validates them and decrypts them, and then acts on them. Okay? Validates them and then acts on them, and it then sends out another wave message to do some control based on that. So for those of you who are sort of moving rapidly through this, don't feel like you have to wait for me. There are some interesting tutorials like bonus exercises at the end. So feel free to go ahead. If you get stuck further ahead, feel free to raise your hand and ask a question. You don't have to follow along with me. Okay, so if anyone is anyone still working on this cell? Okay. So now comes the really exciting stuff. Oh, sorry, firstly, before we move on, it's very important that you run this cell here. You've basically set up this autonomous controller that controls your light, but we're now going to do more exercises that use your light. So if you don't run the cell, those two controllers are going to fight with each other. So you need to run this cell here that sort of subscribes to the same resource and replaces it with a no-op, just so that your controller stops working. So after you run this, your light will no longer be tied to the occupancy signal. So just remember that if later on in your notebook you see your light is behaving crazily, maybe you forgot to run the cell. So now what we're going to do is we're going to interact across namespaces. It's all very well to use Wave within your own house, but the true advantage of Wave is that it allows federation across namespaces because you don't have to trust the Wave server. And if you don't have to trust it, that means multiple companies, multiple parties can use the same server without having to trust each other to be the administrators of that server. So you need to pick a partner, maybe someone next to you, or maybe someone behind you. Everyone sort of identify who your partner is going to be. You need to work in pairs. You might need to move if you're the only person in your row. You might need to move down and find someone next to you. And then you need to negotiate with your partner a nice, cool partnership name. So this, like your nickname earlier, needs to be unique. Otherwise, you're going to see some traffic from other people. So I recommend that you pick something, maybe like the concatenation of your unique nicknames or something. And then what you're going to do once both people have filled in this cell, you're just going to run it at roughly the same time. So roughly the same time means within 3 seconds. So I'll give you a little while to do this. I don't have a partner. And so what you're going to do, I unfortunately can't demonstrate this just yet. I think Mustafa is going to be my partner. I don't know where he is. Oh, there. Can you read my super unique nickname, partnership nickname? You may need to move closer. Come sit here. Unfortunately, no. So this works in pairs. And the exercises, unfortunately, are also a little bit asymmetric. One partner does a bunch of exciting stuff and the other one not so much. However, you can swap afterwards. So once you've done that exercise once through with partner 1 and partner 2, you can swap afterwards. So just tell me when you're ready to run. And what you're going to do is, when you fill this in, you're going to run the cell, and it should print out your information and your partner's information. And what you're going to do is you're going to copy for each of those 3 things that is printed out for your partner, you're going to copy it into the cell below. So this is basically, you ready to run? Super unique, don't copy this. Capital S, capital U, capital D. You ready? Okay, let's go. So if you don't run it at the same time, or you have the wrong nickname, you will only see your own information. Okay, go. So as you will see, my partner's nickname and entity hash and everything is being printed. You need to copy this into the cell below. Be very careful that you don't paste your own nickname and your own entity hash. So after you do that, just run the cell and the variables will be defined, and now you get into the first sort of interesting cross-domain exercise. you need to decide one of you is going to have your lights controlled, and one of you is going to do the controlling of your partner's lights.